Welcome back to Project Aviate. Today we're going to dive deep into one of the most fascinating innovations in modern aviation, something that has completely changed how pilots control aircraft, the fly-by-wire system. If you've ever wondered how giant airliners or cutting-edge fighter jets respond so smoothly and precisely to pilot inputs, the answer lies in this incredible technology. Stick with me until the end, because by the time we're done, you'll understand why fly-by-wire is considered the nervous system of modern aviation. Now, when you step inside a modern cockpit, the first thing you notice is how digital and futuristic everything looks. The glowing screens, sleek control panels, and the absence of the old bulky yokes in some aircraft immediately stand out. This is where the fly-by-wire journey begins. Instead of relying on heavy mechanical linkages and steel cables running from the cockpit to the control surfaces, fly-by-wire replaces all of that with electronic signals. Imagine the difference between writing a letter and sending a WhatsApp message. One takes time and effort, the other is instant. That's the transformation fly-by-wire brings to aviation. If you look at an Airbus cockpit, you'll see pilots using side sticks instead of the traditional control column. When the pilot makes a movement, that motion doesn't pull on cables like older aircraft. Instead, sensors capture the input and convert it into digital signals. These signals are sent to onboard computers, which then decide how best to move the control surfaces, ailerons, elevators, and rudder, to achieve the desired maneuver. It's fast, it's precise, and it allows the aircraft to handle in ways that mechanical systems simply can't. To really understand this, think of the aircraft as a living body. The pilot's hands are the brain sending commands, the computers are the nerves transmitting those commands, and the control surfaces are the muscles executing them. In older planes, those nerves were made of metal cables. In fly-by-wire aircraft, they've been replaced by lightning-fast digital impulses. It's like upgrading from an old landline to fiber optic internet. The speed and reliability are on a completely different level. Let's compare. Traditional aircraft used pulleys and cables. They were heavy, required constant maintenance, and could be damaged over time. Fly-by-wire systems replace all of that with lightweight wiring, sensors, and computer processors. Not only does this reduce weight, but it also increases safety because the system is built with redundancy. That means there isn't just one computer controlling the aircraft. There are multiple computers working simultaneously, constantly checking each other's work. If one fails, another takes over instantly, so the aircraft remains under control. And it's not just commercial jets that benefit. Modern fighter jets rely on fly-by-wire even more. In fact, some fighters like the F-16 or F-35 are aerodynamically unstable by design. Without constant computer adjustments made possible by fly-by-wire, they would literally fall out of the sky. The system allows these jets to perform extreme maneuvers that would be impossible with mechanical systems. Pilots can focus on tactics and mission objectives, while the computer handles the micro-adjustments needed to keep the aircraft stable. The beauty of fly-by-wire is in how it processes pilot commands. Imagine this flow. The pilot moves the control, sensors detect it, signals go to the computer calculates what's needed, and then actuators move the control surfaces. All of this happens in fractions of a second, so to the pilot it feels completely seamless. And because it's computer-controlled, the system can filter out dangerous commands. For example, if a pilot accidentally pulls too hard and risks overstressing the airframe, the fly-by-wire system can step in and limit the movement, protecting both the aircraft and the passengers. Take the Airbus A320, the first commercial airliner to fully adopt fly-by-wire technology. Its system has multiple protections built in. It prevents stalling, excessive banking, or overstressing the structure. Pilots still have authority, but the computer ensures they stay within safe limits. This concept is called flight envelope protection, and it has saved countless lives by preventing accidents that could have occurred in older designs. Now picture this: a pilot in the cockpit places their hand on the side stick. The moment they make an input, a stream of invisible digital data races through the aircraft. It passes through multiple computers, each cross-checking the other, and finally reaches the actuators that move the control surfaces. Ailerons tilt, elevators adjust, rudder shifts, and all of this feels effortless. It's almost like flying a machine that can read your mind. From a design perspective, fly-by-wire also unlocks new possibilities. Aircraft can be made lighter and more fuel-efficient, since there's no need to accommodate heavy mechanical linkages. Engineers can also design more advanced aerodynamics, knowing that the computer will keep the aircraft stable. That's why modern aircraft like the Boeing 787 Dreamliner or the Airbus A350 feel smoother, quieter, and more responsive in flight. But what about safety? Some people worry that relying on computers makes things riskier. After all, what if the system fails? The reality is, fly-by-wire systems are some of the most redundantly designed technologies in aviation. A typical airliner might have 3 or 4 independent flight control computers. If one malfunctions, another instantly takes over, often without the pilot even noticing. And in extremely rare cases, there are backup mechanical systems for the most critical controls. The redundancy is so extensive that the chances of total failure are astronomically low. Fly-by-wire also plays a major role in pilot training. In simulators, the exact same digital logic can be replicated, allowing pilots to practice every possible scenario before stepping into a real cockpit. This means better preparedness, safer flights, and smoother handling even in unexpected situations. Think about maneuverability too. A fly-by-wire fighter jet can perform a cobra maneuver, where the nose pitches up nearly vertical while the aircraft continues forward. Without fly-by-wire, that would be uncontrollable. On the other side, a giant airliner landing in strong crosswinds can adjust its control surfaces with incredible precision, giving passengers a smooth and safe touchdown. All of this is thanks to the computer-assisted magic of electronic flight controls. To summarize, fly-by-wire is more than just a replacement for cables and pulleys. It's an entire philosophy of control. It blends human decision-making with computer precision, allowing aircraft to be safer, more efficient, and more capable than ever before. From the moment the pilot touches the side stick to the instant the aircraft responds, every movement is a carefully calculated dance of signals, sensors, and actuators. It is the invisible force that makes modern aviation possible. So the next time you step onto a commercial jet or watch a fighter streak across the sky, remember that beneath the sleek metal and roaring engines lies a nervous system of digital signals, working tirelessly to keep the machine stable, safe, and smooth. That's the fly-by-wire system, the silent partner that has revolutionized aviation forever. And with that, thank you for watching Project Aviate. If you enjoyed learning about the fly-by-wire system and want to see more deep dives into aviation technology, make sure to like, share, and subscribe. There's a lot more sky to explore, and I'll see you in the next one.